We use a lot of products such as plastic products manufactured in factories in our daily life. Have you ever thought how these products are made and what are they made of? At the end of this lesson, you should be able to explain, through examples, heat changes that occur during industrial chemical reactions, that is, contact process. Explain, through examples, heat changes that occur during industrial chemical reactions, that is, Haber process. The manufacturing of ammonia and sulfuric acid are the most important chemical industries at the present time. The production of sulfuric acid and liquid ammonia involves heat changes that occur during industrial chemical reactions. Ammonia is used to make artificial fertilizer, liquid ammonia, and textile products. Sulfuric acid is used to make plastic products, coloring, cooling agent, as well as electrolytes in lead accumulators. The manufacturing of sulfuric acid in chemical industry involves a process called contact process. It is an exothermic reaction. There are 3 important stages in contact process. Let us see how contact process is carried out in the industry. Click on the stages to learn about it. Burning of sulfur in the air produces sulfur dioxide. Sulfur dioxide, which is produced in stage 1, is mixed with more oxygen and passed through over catalyst vanadium 5 oxide at temperature between 450 to 500 degrees Celsius and 1 atmospheric pressure. This reaction is reversible and heat is released. The sulfur trioxide that is being produced is dissolved in concentrated sulfuric acid to form liquid oleum. Oleum is then diluted with an appropriate quantity of water to produce sulfuric acid. One of the most important chemical process in the industry is Haber process. Ammonia is widely produced in the manufacturing industry to yield their new product. Let us see how ammonia is being produced using the Haber process. Click buttons A to E to know and understand the steps of the Haber process. A mixture consisting 1 part of nitrogen and 3 parts of hydrogen gas is compressed to a pressure of 200 to 500 atm. Mixture of hydrogen and nitrogen is passed through catalyst of iron at temperature of 450 to 550 degrees Celsius. Ammonia gas is produced. The mixture consists of about 15% ammonia gas. This mixture undergoes condensation process. Liquid ammonia is collected in collecting chamber. Unreacted nitrogen gas and hydrogen gas are pumped to the chamber to be reacted again.
Sulfur is burnt in air with the presence of oxygen to form sulfur dioxide. Sulfur dioxide is mixed with excess air at a temperature of 450 degrees Celsius to 500 degrees Celsius, pressure at 1 atmosphere, and with the presence of vanadium 5 oxide catalyst to form sulfur trioxide. Sulfur trioxide is dissolved in concentrated sulfuric acid to form oleum. Finally, oleum is diluted in water to form sulfuric acid. What is the function of the catalyst? What happens if the vanadium 5 oxide catalyst is not used for the reaction of sulfur dioxide and oxygen? Discuss. Click on vanadium 5 oxide to know. The catalyst speeds up the reaction. Without the vanadium 5 oxide catalyst, the oxidation of sulfur dioxide would be slow. The reaction of sulfur dioxide with oxygen to produce sulfur trioxide is exothermic. While the decomposition of sulfur trioxide to sulfur dioxide and oxygen is endothermic. What would happen if the temperature is raised or lowered? Click on the equation. High temperature causes sulfur trioxide to decompose back to sulfur dioxide and oxygen. On the other hand, if the temperature is too low, it will slow down the formation of sulfur trioxide. The optimum temperature is 450 degrees Celsius to 500 degrees Celsius. What are the uses of sulfuric acid? Click on sulfuric acid to know. Chemical fertilizer. Detergent. Electrolyte in car batteries. Plastics. Paint pigments. Polymers. Who was the first man to develop the Haber process? Click Haber Process to find out. It was developed by Fritz Haber in 1909. Where did the raw materials come from? Click nitrogen to find out. Nitrogen is obtained from the air and hydrogen is generated from natural gas in a process called steam reforming. Is the Haber process reaction exothermic or endothermic? Discuss. Click the equation of nitrogen reacting with hydrogen produces ammonia, and the process is reversible. The forward reaction is exothermic. The reverse reaction is endothermic. What will happen if the temperature is raised or lowered? Click Temperature 450 degrees Celsius to 500 degrees Celsius. High temperature causes ammonia to decompose back to nitrogen and hydrogen. On the other hand, if the temperature is too low, it will increase the formation of ammonia. However, the rate of the reaction is slow. The optimum temperature is 450 degrees Celsius to 500 degrees Celsius. Can you list the uses of ammonia? Click Liquid Ammonia to find out. Chemical fertilizers. Ammonia to prevent latex from solidifying. coolant agent. Plastics. One. What is the process shown below? A. The Haber process. B. The Down process. C. The contact process. D. The Oswald process.
Your answer is correct.
2. Which is the correct statement to describe contact process? A. This reaction is endothermic. B. Nitrogen is used as a raw material. C. It is the process to produce hydrochloric acid. D. Oleum is dissolved in water to produce sulfuric acid.
Your answer is correct.
3. The manufacture of ammonia commercially involves the use of nitrogen gas and hydrogen gas in the ratio of A. 3:1, B. 2:3, C. 1:3, D. 1:2.
Your answer is correct.
4. All the items below are factors influencing the optimum production of ammonia except A. Pressure at 200 atm. B. Iron powder as catalyst. C. Ratio of nitrogen to hydrogen is 3:1. D. Optimum temperature of 450 degrees Celsius to 500 degrees Celsius.
Your answer is correct.
Which products can be formed from ammonia? 1. Nylon. 2. Coolant agent. 3. Chemical fertilizers.
Your answer is correct.
Answer the following question based on the diagram above. 1. Name the process above. Haber process. 2. Identify the following substances. A. X. B. Y. C. Z. A. X. Hydrogen. B. Y. Nitrogen. C. Z. Iron. Three. Name 3 usages of ammonia. Chemical fertilizer, nylon, and washing agents.
In this lesson, we have learned that heat changes occur during an industrial chemical reaction. The first industrial chemical reaction we learned is contact process. Firstly, sulfur is burnt in oxygen. This process loses heat. Next, sulfur dioxide produced is burnt in air. This process loses heat. Then, sulfur trioxide is dissolved in concentrated sulfuric acid. Oleum is dissolved in water. This reaction also loses heat. Finally, sulfuric acid is produced. The second industrial chemical reaction we are going to learn is the Haber process. Firstly, nitrogen and hydrogen are mixed together at a ratio of 1:3. The mixture is next put inside a reactor. Reaction occurs at the pressure of 200 atm, temperature of 450 degrees Celsius to 500 degrees Celsius, and using iron as a catalyst. Ammonia gas produced is condensed to form liquid ammonia. The reaction between nitrogen and hydrogen to produce ammonia is an exothermic reaction. This means that heat energy is released in this process. Whereas, decomposition of ammonia to nitrogen and hydrogen is an endothermic reaction. This means that heat energy is absorbed in this process.
Ammonia is widely used in fertilizers. Ammonia-based fertilizers are mainly used to reduce acidity and improve quality of the soil.